All right, so today we're going to take a look at 312, and there's some really cool Pythagorean identities here. So a squared plus b squared equals c squared. So if we were to draw right anywhere on the unit circle, cosine, sine, and 1. So our Pythagorean identity is sine squared of x plus cosine squared of x equals 1. It's our a squared plus b squared equals c squared. And now we could rearrange these. For example, if I was to subtract the cosine squared, I know the sine squared would equal 1 minus cosine squared of x. Or if I was to take this original and subtract the sine squared, cosine squared of x equals 1 minus sine squared of x. And now everything comes back to these bases here. So we can find some reciprocal identities, and they can be found by dividing by the sine squared of x. So sine squared over sine squared is 1. Cosine over sine, well, that's our cotangent squared of x. 1 over sine is the cosecant squared of x. And then we could rearrange these as well. And we get a different one if we divide these by the cosine squared of x. So sine over cosine, so that's our tangent squared of x. Cosine over cosine is 1. 1 over the cosine is the secant squared of x. So these are all different identities, but they all stem from that sine squared plus cosine squared equals 1. So use trig identities to establish this. So a couple things we need to remember. What does tangent of x equal? Well, tangent we know is sine over cosine. So cotangent of x is cosine of x over sine of x. Cosecant of x is 1 over the sine of x. And the secant of x is 1 over the cosine of x. So these are a lot like a puzzle. Can you rewrite these for a single trig identity? So tangent, if I was to rewrite that, sine of x over cosine of x times the cosine of x, I end up with just the sine of x. So that's a single trig function. 1 minus the cosine. Well, I think Pythagorean theorem, anytime we have that. So if 1 minus that cosine on top, well, that's our sine squared. So this is really sine squared of x over cosine squared of x. And sine over cosine's tangent, so this is the tangent squared of x. All right, what about this one? Well, cosine squared plus sine squared, that's a squared plus b squared, so the top is just 1 over the sine of x times 1 over the cosine of x. So this is 1 over the sine of x over the cosine of x, which would be 1 times cosine x over sine of x, which is just equal to the cotangent of x. So some tips for these is rewrite in terms of sine and cosine, check the Pythagorean identity, and put in terms of one trig function. So we're asked to solve a couple of these. So the first thing you want to do when solving is get it into one trig function. So let's see. 1 equals, what is cosine? 1 over the cosine squared of x plus sine of x over the cosine of x. Well, what do we need to add fractions? We need a common denominator. So let's see. We don't have a common denominator there. So what can we do on this one to try and get a single trig function? Well, I do recognize, wait, let's see, that didn't get me anywhere. So let's try something else. Is this a Pythagorean identity? So this is 1 minus the secant squared of x equals the tangent of x. So is that an identity? Let's see. I know sine squared plus cosine squared equals 1, and I want secant. So that's 1 over the cosine. So if I divide by cosine, sine over cosine, so tan squared of x plus 1 equals the secant squared of x. So what if I did minus 1, right? So now I have tan squared of x, secant squared of x minus 1. So I could rearrange this, right? If I did 0 equals secant squared of x minus 1 plus the tangent of x, that's now equal to the tan squared of x plus the tangent of x. And we know how to solve that. Factor out a tangent. The tangent of x times the tan of x plus 1. So when does this equal 0? When the tangent of x equals 0 or the tangent of x plus 1 equals 0? Well, where does our tangent, y over x equals 0? Well, it's when that equals 0. So where does our y equal 0? Would be at 0, pi, and 2 pi. And this one, where does our tangent of x equal negative 1? Well, that's when they're the same side length, and one is positive and one is negative. So that's our root 2 over 2's and negative root 2 over 2's. So that would be 3 pi over 4 and 5 pi over 4. 7 pi over 4, sorry. And how about this last one? 1 minus the sine squared. Ooh, this one's going to be easier, I get the feeling, because we know sine squared of x plus cosine squared of x equals 1. So 1 minus sine squared. So that whole thing is cosine squared of x plus cosine squared of x equals 2. So this is 2 cosine squared of x equals 2. Divide by 2. So cosine squared of x equals 1. Square root, so either the cosine of x equals 1 or the cosine of x equals negative 1. So where does that happen? Is at 0, pi, and 2 pi.